So we're going to cover section 5.2, which is multiplication and division of rational expressions. So rational expressions are really just fancy fractions. That's all they are. So when we're multiplying rational expressions, we're going to use the same principles that we use with regular fractions. So our first step, factor the numerator and the denominator of each expression. Then we're actually going to reverse steps 2 and 3, and we're first going to reduce the ratios of common factors. And then lastly, we'll multiply the numerators and multiply the denominators. So let's just go ahead. Let's look at an example here. So here's an example where the first thing we're going to do is take this denominator and we'll factor it. We'll factor it into x plus 7, x minus 6. Then we're going to go ahead and take that second rational expression, look at the denominator. Oh, that's a difference of 2 squares. We'll factor it. So now what we can do is you can either put everything together, which is right here, like in step 2, and then we can just go ahead and reduce. X plus 2's, those equal 1. X plus 7's, those equal 1. So then everything that's left is 1 times 1. So we have a 1 in the numerator, and then we've got the x minus 6 and the x minus 2. We bring it over, there's our answer. Not so bad. Let's go ahead and look at this first example. So I look at this as if I have 4 separate problems. So I'm just going to go ahead and put 2 fraction bars. So I'm going to take this first numerator, and then I'm going to put my answer after I factor it right there. So I take out a 3, and I've got p minus 1. Okay? I can't do anything with that denominator. It's just a p. Let's put it there. Now over to the right, we've got a 7p squared. What's really helpful here is if I just expand those p's. It's just going to make it easier to reduce. And then in the denominator, we can go ahead and take that 8p minus 8, and we're going to factor out a greatest common factor of 8, and we're left with p minus 1. So now that everything is factored, expanded, we can go ahead and reduce. So I'm going to reduce the p minus 1's, and then a p, and then I can just go ahead and multiply across. So that's going to give me in the numerator 21p, and in the denominator 8. That's my answer. All right, let's go ahead and look at problem number 2. So first thing I'm going to do is I am going to put my fraction bars, and then I start with my upper left, okay? And I'm going to put my factored form right there. So that is the difference of 2 cubes. So that's going to be x minus 3 times x squared plus 3x plus 9. Now, one of the things we didn't mention in the earlier sections is that trinomial that follows the binomial here, that is prime. It can't be, meaning it can't be factored any further. Even though it looks like potentially it could be a perfect square trinomial, it never will be. It is an imposter. So in the denominator of that same rational expression, I have a difference of 2 squares. So when I go ahead and put that into its conjugates, into the factored form, it's x minus 3, x plus 3. Now I can go over to the second rational expression, and let's look at that numerator. Well, that looks like a difference of 2 squares. And so that's going to be x minus 3, x minus 3. Okay? which it's x minus 3 squared. All right, and then this actually denominator, I'm going to put right here, I can't do anything with that. That actually is prime. So I've got x squared plus 3x plus 9. So now I am all set to reduce. So I can take this x minus 3, x minus 3. This trinomial with this trinomial, they're exactly the same. And that's all I can reduce. So now I am left with x minus 3 squared over x plus 3. That's my final answer. All right. So let's go ahead and look at example 3. So let's start here with our numerator. And so I've got x squared minus 11x plus 30. And so that's going to, well, actually I forgot to do my 2 fraction bars. So that is going to become x minus 5, x minus 6 in factored form. Then I can go ahead and look at my denominator of that same rational expression. And so I can take out an x squared, and I'm left with 3x plus 2. Now I've got my numerator of my second rational expression, and that, if I take out an x, so let's be careful with this. So if I take out an x, I would be left with 9x squared minus 4. Well, that 9x squared minus 4 is a difference of 2 squares. So in factored form, this is x times 3x minus 2 times 3x plus 2. Well, that's pretty nifty. And then lastly, we can go ahead and look at that denominator where we can take out a 4, and then we're left with x minus 5. Okay, so as we reduce now, I've got the x minus 5s that reduce to 1. I don't have any x minus 6s in the denominator, but I can take this x and I can take out one of those x's, okay? And that leaves us with 1. And then the 3x plus 2. And it looks like that is everything. And so when I multiply across, I am left with x minus 6, 3x minus 2 in my numerator. Then in the denominator, I just have 4x. And that's all. Okay. So one of the questions you might be asking by now is, hey, why isn't she reducing like those 2 x's? That's a really good question. And I often get that. That's because in this, in the numerator, my factors, the things that are being multiplied, are my 2 binomials. But inside of those binomials, that's a term. And I can only reduce factors, things that are being multiplied together. I can't reduce things that are added or subtracted. All right. Let's go ahead and look at this last example. So let's start here with upper left, and that is going to be, it's the difference of 2 squares. So y minus 7, y plus 7. And then for that denominator, I can go ahead, take out a 7, and I'm left with y plus 7. Over on the right, I've just got the y minus 1, and then the 7 minus y. All right, so let's go ahead and reduce. So just to start off, this y minus 7 and the 7 minus y, almost the same, but they're in opposite order. So I can reduce them. However, they don't reduce to a positive one. They reduce to a negative one. All right, now I've got the y plus 7s. They reduce. And that's about everything. So I'm going to go ahead, multiply across. So when I multiply across, I am left with, you can go ahead and put this negative out front from this -1. And then you've got a y minus 1. I'm going to use the parentheses over a 7. That's my answer. Okay, so multiplication, pretty straightforward. We just factor, top, bottom, reduce, multiply across. So what's so different about dividing? Really, not a lot. So the only thing with dividing is we are going to change it to a multiplication problem. How do we do that? Well, we kind of use a little saying, which is keep, change, flip. So what does that mean? Well, it means you keep the first fraction. So, or you could say rational expression. Change the division to multiplication, and then you flip the second rational expression. Okay? All right. So here we have our first example. And so we're going to keep that first rational expression. We are going to change this division. It gets changed to multiplication. And then for the second rational expression, we're going to flip it. So the 5m goes to the top, the 6m minus 6 goes to the bottom. Now that it's a multiplication problem, we can follow the same process that we were just using. So I'm going to take that 5m minus 5, and all we do is factor it. So that's where we get 5 times m minus 1. The m stays in the denominator. And then for that 5m squared, we just go ahead and we expand it out. For that denominator, we go ahead and we factor out that greatest common factor of 6. So then it becomes very easy to reduce, okay? The m minus 1s reduce, the m's reduce, and that's about all. So then we are left with 25m over 6. Okay, let's go ahead. Try some more examples. So we want to go ahead, keep the first rational expression. So that's going to be 50 x to the 11th over 30 y to the 8th. Then we're going to take this division, change it to multiplication. Then we're going to flip the second rational expression. So we bring the 30y cubed to the top and the 30x to the 6 to the bottom. So I didn't try and reduce anything or factor anything while I was prepping. Okay? Now we can go ahead and we can do all that reducing. So the first very obvious thing that I can see is this 30 and this 30. Just got to get rid of them. Okay? Then the 50 and the 30, I can divide both by 10, which really gets rid of the zeros. Now I have my x to the 11th and my x to the 6th. So if I take 11 minus 6, my x to the 6 goes away, and that 11 becomes a 5, because 11 minus 6 gets us to 5. I can do the same process with the y's. I have 8 y's on the bottom, 3 y's on the top. So I get rid of the 3 on top, and then this 8 y becomes 5. 8 minus 3 is 5. Okay, or you could think of it as 3 minus 8 is a negative 5. That negative 5 means it goes to the bottom. So our final answer is going to be 5x to the 5th over 3y to the 5th. There we go. All right, let's go ahead and do the second one, or example 6. All right. I'll just move this out of our way. Okay. So let's look at upper left. I'm going to go ahead, take my fraction bar. Actually, let me do this in 2 steps. So z squared minus 81 over z times, and then let's flip this, z plus 7 over z plus 9. Okay, so now we can go ahead and we can take that z squared minus 81, and that's a difference of 2 squares. Let's change that to z minus 9, z plus 9. All right, so now that everything is factored, we can go ahead and reduce. The z plus 9s, we can go ahead and reduce those. And so then we're left with z minus 9, z plus 7, all of that over that lovely z. We do not multiply our numerators. We can keep that in factored form. It's just fine. All right, let's look at number 7. So for problem number 7, first thing we want to do, prep it. Okay, so here's our 2 fraction bars. And so I'm just going to take 27y cubed minus 512 over 512y cubed minus 125 times. And let's bring this 64 to the top. 64y squared plus 40y plus 25. All over that 9y squared minus 64. Okay. So I'm going to go ahead and I'm going to have 2 rational expressions. So let's go ahead and take that 27y cubed minus 512. And so our a on that is right here. I'm going to write this. Let's do it in a different color. Okay, so our a here is going to be 3y. 3 cubed gives me 27. Then for the 512, that one is going to be 8. So the cube root of 512 is just simply 8. All right, so this is going to give me 3y minus 8 times 9y squared plus 24y plus 64. Okay, now for our denominator, oh, I didn't mean to do that. It's okay. Let's see. Let's just kind of catch up here. So here's our denominator. We're going to do the same process. So we have got this 512y cubed. That's going to be our a. It'll be 8y. And then our b, the cube root of 125, is 5. So that's going to be 8y minus 5 times 64y squared plus 40y plus 25. Now I'm going to go ahead and I've got to take this 64 y squared plus 40y plus 25. Notice that that's the same as that trinomial after my difference of 2 cubes. So I know that it's prime. So I'm just going to rewrite it. So that is going to be over here, 64y squared plus 40y plus 25. And then my denominator is simply a difference of two squares. And so that's going to be 3y plus 8, 3y minus 8. Okay, now that everything is set up, this is going to be easy for us to do. I can take the 3y minus 8, the 3y minus 8, that's 1. That 9y squared, that's going to stay, but the 64, that whole trinomial gets reduced. So now I can see, I can multiply everything across, keeping it in factored form. So that's going to give me in the numerator 9y squared plus 24y plus 64. In the denominator, I have 8y minus 5 and 3y plus 8. There we go. That one is done. Now, for number 8, okay? This is a crazy, crazy one. This is going to be the last one that we do, okay? So I'm going to go ahead and I'm going to keep my first rational expression. I'm going to keep this one. I'm going to change my division to multiplication. I'm going to flip my second rational expression, change my second division to multiplication, and flip my third one. Okay, so what is that going to look like? So I've got, I'm going to break one of my rules, and I'm actually going to factor at the same time. So r plus s, r minus s, over, I'm going to take that r minus s times r minus s. So that is my first rational expression. Then a multiplication sign. Now I'm going to take this denominator. Oh, that would look like a perfect square, except I can tell that middle term needs a 2, so it's not correct. So that's prime. I shouldn't say it's not correct. I should say it's prime. So r squared minus rs plus s squared. Now, that numerator of that same rational expression, that is a perfect square. So that's going to be r minus s squared. All right, so now I've got my times, and I've got another r minus s, but this one's to the 4th. And then I've got my numerator here, which is going to come down to my denominator. So that is the sum of 2 cubes. Okay, so that's going to be r plus s times r squared minus rs plus s squared. Okay, now we get to have some fun, and we can reduce. All right, so we've got the r plus s, the r plus s. That's 1. The r minus s and an r minus s. That reduces to 1. The r squared minus rs plus s squared. That reduces to 1. Now I have in my denominator 1 plus 2 more r minus s's. So I have 3 in the denominator and I have 4 in the numerator. So the denominator, they all cancel, and that r minus s goes to an exponent of 1. So this whole thing is just r minus s. Crazy. All right, so you have enough where you can successfully complete the homework. And yeah, you should feel good about that.